AASHTO T84 and ASTM C128 are the standard method of test for the specific gravity and absorption of fine aggregate. The relative density or specific gravity test will identify the physical properties of the fine aggregate. A change in this number will increase or decrease the amount of volume of fine aggregate in a given concrete mixture. Absorption is a measurement of water that is in the concrete pores. When the pores are completely filled but there is no surface moisture, the sand is considered to be in the SSD condition. An increase in moisture or decrease in absorption will change the amount of water in a given concrete mixture. We will now review the steps of AASHTO T84 and ASTM C128. Once again, these steps come directly from the Technician's Handbook. Testing fine aggregate for specific gravity and absorption is unique in the fact that it is done in two steps. First, we must test it to make sure that it is in the SSD condition. Then we can proceed. We do this with a mold and a tamper. The tamper weighs 340 grams plus or minus 15 grams, while the tamping face must be round and flat with a diameter of 25 millimeter plus or minus 3 millimeters. The mold is in the shape of the frustum of a cone with the following dimensions. The inside diameter at the top shall be 40 plus or minus 3 millimeters, while the inside diameter at the bottom shall be 90 plus or minus 3 millimeters, and the height will be 75 plus or minus 3 millimeters. We will also be using a heat gun to provide a warm stream of air and assist us in getting the sample to SSD. To perform the cone test, we want to hold the cone firmly on a flat, non-absorbent surface. We then want to add material into the cone, filling it to overflowing, heaping additional material over the top as necessary. We then want to tamp the material into the mold with 25 light drops of the tamper. The tamper should be approximately 5 millimeters above the fine aggregate for each drop. We now want to lift the mold vertically. If moisture is still present, the fine aggregate will retain its molded shape. However, when the fine aggregate slumps slightly, we have reached the saturated surface dry condition. Now that our material is in the saturated surface dry condition, we can begin the procedure. To perform the specific gravity test, we will need a mason jar and lid. A balance. For AASHTO, this balance shall meet classification M231 Class G2, while for ASTM it must be accurate to 0.1 gram or 0.1% of the sample mass. And finally, an oven with a range of 110 degrees plus or minus 5 degrees Celsius. To begin our test, we want to partially fill our mason jar with water. Next, we want to weigh out 500 plus or minus 10 grams of saturated surface dry fine aggregate. Be sure to record the exact amount that you've weighed out. We now want to introduce our saturated surface dry specimen into the mason jar. Once the sample is into the mason jar, we want to reintroduce water into the mason jar and fill to 90% of capacity. Now that all of our materials are back into the mason jar, we want to roll, invert, and/or agitate our mason jar. We can also use mechanical methods to ensure that we remove all of the air bubbles. Once all the air bubbles have been removed, we want to adjust the water temperature, if necessary, to 23 plus or minus 1.7 degrees Celsius. Remember, for ASTM this is 23 plus or minus 2 degrees Celsius. by immersion in a circulating water bath. Once this is complete, we can bring the water level back to the calibrated mark. We now want to record the weight of the mason jar, the specimen, and the water filled to the calibration mark. Be sure to record this and all subsequent weights to the nearest 0.1 grams. We can now remove the fine aggregate from the mason jar, place it in a bowl, and dry it to a constant mass. We dry our sample by placing it in an oven that has a temperature of 110 plus or minus 5 degrees Celsius. Once we remove our sample from the oven, we want to allow it to cool for 1 plus or minus 0.5 hours, and again record the mass of the now dry sample. We now want to fill the mason jar with just water back to the calibrated mark. Be sure that the water's temperature is 23 plus or minus 1.7 degrees Celsius. Then record this weight to the nearest 0.1 grams. Now that we've completed all the physical aspects of our tests, we can go ahead and do our calculations. When we have completed our test, we should have 4 weights recorded. The first is listed as A. This is the weight of the oven dry specimen. Next is B. This is the weight of the mason jar filled to the calibration point with just water. Next is S. This is the weight of the saturated surface dry specimen. And finally, C. This is the weight of the SSD specimen in the mason jar with the water filled to the calibration mark. For our example, let's assume that A, the weight of the oven dry specimen, is 495.6 grams. For B, the weight of the mason jar with just the water, let's assume our weight is 1,202.3 grams. Let's assume that S, the weight of the saturated surface dry specimen, is 501.1 grams. And finally, C. This is the weight of the SSD specimen in the mason jar with the water filled to the calibration mark. For our example, let's assume that weight is 1,514.4 grams. And here are those weights listed individually. Our first calculation will be to calculate the bulk-specific gravity of our material in the SSD condition. We do this by taking the weight of the SSD specimen and dividing it by the weight of the mason jar filled with just water plus the weight of the SSD specimen, and subtract from this weight the weight of the SSD specimen with the mason jar filled with water to the calibration mark. So if we simply plug in our numbers, our calculation should read 501.1 grams divided by 1,202.3 grams plus 501.1 grams minus 1,514.4 grams. And this should give us 501.1 grams divided by 189 grams for a specific gravity of 2.65. Now let's go ahead and calculate our absorption. The calculation for absorption is S minus A divided by A times 100, where S is the weight of the SSD specimen and A is the weight of the oven-dried specimen. And again, we simply now plug in our numbers, so 501.1 minus 495.6 divided by 495.6 times 100. And if we do the math, we should wind up with 5.5 grams divided by 495.6 grams, which should give us 0.011. And if we take the 0.011 and times it by 100, we should wind up with an absorption for our fine aggregate of 1.1%. We will now review the steps of AASHTO T84 and ASTM C128, specific gravity and absorption of fine aggregate. And listed here for your review are the deviations between AASHTO and ASTM.